You just deleted a file. You watched it vanish. The icon disappeared. The folder emptied. It felt final. It felt clean. But it isn't gone. Not even close. Right now, on the drive inside your device, that file is still sitting there. Every byte, every pixel, every word, untouched, waiting. What you actually deleted wasn't the file. It was the address. The little note that told your computer where to find it. Think of your storage drive as a massive library with no card catalog. Millions of books packed onto endless shelves. When you save a file, your computer writes the data onto a shelf, then makes a tiny index card that says exactly where it lives. When you delete a file, your computer doesn't burn the book. It rips up the index card. The book stays exactly where it was. Silent, unlabeled, invisible to you, but still there. Why would a computer work this way? Speed. Actually erasing every byte of a large file takes time. Ripping up one small card takes almost none. So your operating system takes the fast path. It marks that space as available and moves on, the same way a hotel might mark a room as empty without actually cleaning it first. This is called a soft delete, and it's the default behavior across almost every major operating system going back decades. An engineer named Ken Thompson helped build this logic into Unix back in 1969 at Bell Labs. He wasn't trying to make deletion reversible. He was trying to make computers efficient with the tiny, expensive storage of the era. That efficiency shortcut is still running underneath your phone and laptop today, more than 50 years later. So where does your deleted file actually go? On most systems, it heads to a temporary holding area. Windows calls it the recycle bin. Mac calls it the trash. Both are really just folders that hide files from your normal view while keeping every byte intact. Empty the bin, and something interesting happens. The file doesn't disappear from the bin into nothing. It disappears from the bin into the same invisible state as before. Unlabeled, unlisted, recoverable, if nothing else has claimed that space yet. This is exactly how digital forensics works. Investigators, hackers, and recovery specialists use tools that scan a drive, not for files, but for orphaned data. Data with no index card pointing to it anymore. If you've ever heard of software like Recuva or EaseUse, this is their entire business model. They're not resurrecting files, they're just reading books nobody labeled. Here's the twist that changes everything. Your deleted file isn't actually safe. It isn't actually gone, but it's not fully alive either. It exists in a kind of limbo, and that limbo has an expiration date, even if nobody can tell you exactly when it ends. Every time you save a new file, take a photo, download an app, or even just let your phone do a background update, your device looks for available shelf space. Space marked empty. Space that used to hold your deleted file. If your computer picks that exact spot, it writes new data directly on top of the old data, byte by byte. And once that happens, recovery becomes nearly impossible. Not because the rules changed, because the shelf simply isn't the same book anymore. This means your deleted file's fate is decided by pure chance. How full is your drive? How much new data are you creating? How long has it been sitting there, unclaimed? A photo deleted 5 minutes ago on a mostly empty drive might be trivially easy to recover. The same photo deleted a year ago on a nearly full drive that's been constantly writing new data might already be gone forever, overwritten dozens of times without you ever knowing. There's a reason certain jobs treat deletion so seriously. Government agencies, hospitals, banks, they can't rely on chance, so they use something far more aggressive than a normal delete. It's called secure erasure, and it works by deliberately overwriting the old data with meaningless patterns of ones and zeros, sometimes multiple times in a row. The United States Department of Defense published a standard for exactly this kind of process, once widely known as DoD 5220.22-M. The idea was simple. If the original data gets buried under enough layers of random noise, there's nothing left to recover. Not a fragment, not a trace, but even overwriting has a limit. In 1996, a computer scientist named Peter Gutmann published research claiming that under certain conditions, faint magnetic traces of old data could theoretically still be detected on traditional spinning hard drives even after being overwritten. His work became famous and slightly misunderstood, Most experts today agree a single modern overwrite is more than enough for nearly all practical situations, but the paper reveals something important. On some level, data doesn't like to fully disappear. It leaves a residue behind. Solid-state drives change this story completely. Unlike traditional spinning hard drives, SSDs don't overwrite data in the same simple way. They manage memory in blocks, spreading and shuffling data across the chip to reduce wear through a hidden process the drive controller handles automatically. This is one reason phones and modern laptops now include a secure erase or encrypt and wipe function instead of a traditional overwrite. Overwriting an SSD the old-fashioned way doesn't guarantee the same result it does on a hard drive, which brings up the real question underneath all of this. If deletion is really just hiding, not destroying, what does gone even mean anymore? You already trust an answer to this question every single day. Think about the last time you deleted a text conversation, a search history entry, or an embarrassing photo. You felt a small sense of relief, closure, as if pressing that button rewrote the past. But your phone doesn't work in the past tense. It works in probabilities. The message is gone from your view. It might still be sitting in unclaimed memory, waiting for something to overwrite it. It might be sitting in a cloud backup you forgot existed. It might be sitting in a cached copy someone else's device downloaded before you hit delete. Companies like Apple and Google have both faced this exact tension publicly, explaining in their own privacy documentation that deleted data can persist in backups, caches, and logs for a period of time before being permanently purged from their servers, not because they're hiding anything, because deletion, even at the scale of a global company, is a process, not an instant. So the file you deleted this morning might already be unrecoverable. Or it might still be sitting there, patiently, waiting for a scan tool to notice it. You have no way of knowing which, and neither does your phone. That uncertainty is the real story behind the delete button. It was never designed to erase your past. It was designed to make you feel like it did, while your device quietly kept its options open. Every day, you delete dozens of small pieces of yourself, a blurry photo, a typo-filled text, a search you regret. Each time you get the same reassuring animation, the same satisfying flick into an imaginary void. But nothing in your device was ever built for erasing. It was built for forgetting where to look. You didn't delete the file. You just stopped being able to find it.